mission with the primary objective of putting a lander and rover in the highlands near the south pole of the Moon on 23 August 2023 and demonstrating end-to-end landing and roving capabilities. It will also make a number of scientific measurements on the surface and from orbit. It comprises a lander, rover and a propulsion module. The lander-rover will be similar to the Vikram rover on Chandrayaan-2, with improvements to help ensure a safe landing. It will be carried to lunar orbit by the propulsion module, which will remain in orbit around the Moon and act as a communications relay satellite. Spacecraft and Subsystems. The propulsion module is a box-like structure, modified I3K structure, with one large solar panel mounted on one side and a large cylinder on top, the Intermodule Adapter Cone, that acts as a mounting structure for the lander. The main thruster nozzle is on the bottom. It has a mass of 2,145.01 kilograms, of which 1,696.39 kilograms is propellant for the MMH MON3 bi-propellant propulsion system. It can generate 738 W power. Communications is via S-band, and attitude sensors include a star sensor, sun sensor, an inertial reference unit and accelerometer package IRAP. The Vikram, named after Indian space program pioneer Vikram Sarabhai, lander is also generally box-shaped, 200 x 200 x 116.6 cm with 4 landing legs and 4 landing thrusters. It has a mass of 1,749.86 kilograms, including 26 kilograms for the rover, and can generate 738 W using side-mounted solar panels. The lander has a number of sensors to ensure a safe touchdown, including an accelerometer, altimeters, Ka-band and laser, Doppler velocimeter, star sensors, inclinometer, touchdown sensor, and a suite of cameras for hazard avoidance and positional knowledge. Reaction wheels are used for attitude control, and propulsion is provided by a MMH and MON3 bi-propellant system with 4 800N throttleable engines and 8 58N throttleable engines. An X-band antenna is used for communications. The lander carries the rover in a compartment with a ramp for deployment onto the surface. The Pragyan, Sanskrit for wisdom, rover has a rectangular chassis, 91.7 by 75.0 by 39.7 cm in size, mounted on a 6-wheel rocker bogie wheel drive assembly. It has navigation cameras and a solar panel that can generate 50 W. It communicates directly with the lander via RX-TX antennas. The Vikram lander will carry an instrument called Chandra's Surface Thermophysical Experiment (CHASE) to measure surface thermal properties, the Instrument for Lunar Seismic Activity (ILSA) to measure seismicity around the landing site, the radio anatomy of moon-bound hypersensitive ionosphere and atmosphere (ROMBA) to study the gas and plasma environment, and a passive laser retroreflector array provided by NASA for lunar ranging studies. The Pragyan rover will carry 2 instruments to study the local surface elemental composition, an alpha particle X-ray spectrometer (APXS) and laser-induced breakdown spectroscope (LIBS). The propulsion module orbiter will carry one experiment called the spectropolarimetry of habitable planet Earth (SHAPE) to study Earth from lunar orbit. Mission profile. Chandrayaan-3 launched on 14 July 2023 at 9:05:17 UT 2:35 p.m. India Standard Time, on a GSLV Mark III (LVM-3) heavy lift launch vehicle from Satish Dhawan Space Center in Sriharikota, India, into an approximately 170 by 36,500 km elliptic Earth parking orbit. This will be followed by a number of maneuvers over about 40 days to bring it to the Moon. On the 5th of August, the spacecraft was placed into a 164 by 18,074 km lunar orbit by a 30-minute engine firing. A number of firings by the propulsion module put the lander, rover into a 100 km circular polar lunar orbit by August 17. The Vikram lander then separated. It began its powered descent towards the surface at 12:14 UT on the 23rd of August and landed in the south polar region of the Moon, near 69.37 s, 32.35 e, 19 minutes later at 12:33 UT, 6:03 p.m. India Standard Time. The propulsion module communications relay satellite will remain in lunar orbit to enable communications with Earth. Chandrayaan 2 will also be used as a backup relay. The lander and rover are designed to operate for one lunar daylight period, about 14 Earth days.